So we are given the second derivative of a function is 2x minus cosine, and we want f of x. So we're going to have to work backwards. So I'm going to do the antiderivative of the second derivative. That'll take me back to the first derivative. So this would be x squared minus sine of x plus a constant. And then doing another antiderivative will take me back another step to the original function. So 1/3 x cubed. This would have to be plus cosine of x, because derivative of cosine would be negative sine. And then plus a constant times x, and then plus another constant. If you want to be real particular, you can call this like constant 1 and constant 2, because they can be two different numbers. But this could be like plus 7x or minus 12x, or, you know, plus 1,000,000, whatever you want, just any number. So the one that this matches with would be A. All right, for the second one, this is fundamental theorem of calculus. We're going to do the antiderivative, and then we'll do upper boundary minus lower boundary. What I would do is, first of all, I would write that square root as x to the 1/2, and then I would distribute it into those parentheses before I even try to start this problem. So if we distribute the x to the 1/2, that will give us x to the 3/2 plus x to the 1/2. And so this problem's tough because there's a ton of fractions in it, but we will persevere. All right, so if we add 1 to this power, that will be 5/2, and so a 2/5 out front. And then for this one, if we add 1 to the power, we will get 3/2, and then a 2/3 out front. No plus c, because we're going to actually get a numeric answer. So plugging in 1 to any power is just going to be 1, and then times 2/5, and then same thing here. And then minus, now if you plug in 0 for those x's, you're just going to get 0. So that whole second part of that's going to be gone. And then we're going to need to get a common denominator of 15ths. So this would be 6/15 plus 10/15, so 16/15. So that one, just a lot of fractions is what made that one a little tougher. All right, so this one says, using U substitution like this, what would this be equal to? So we're not going to work it out the whole way. We just need to get as far as doing the substitution. So U is square root of x, and that derivative is 1/2 square root of x dx. Again, probably just want to know square root is 1/2 square root. And then you start looking for that in the problem. Now we have that division by square root of x, but we don't have the division by 2, so I'm going to multiply both sides of this by 2. And then I like to highlight, you can or not, you're actually not allowed a highlighter on the AP exam. You could underline, I suppose. But in place of this division by square root of x dx, in place of that, we're going to put 2 du. So 2 is going to go out front, du is going to go at the end, and what I didn't highlight is still there, which is e to the u. And then the last thing we need to fix are the boundaries. So if I plug in 1 for x, square root of 1 is 1. And if I plug in 4 for x, square root of 4 is 2. And so this one would be C. All right, number 4, what are all the values of k for which this thing would equal 0? And it looks like we have to test -3, 0, and 3. So this would be the area under the curve starting at -3 until wherever of the x squared graph. So just to give us a visual of that, here's our x squared graph. Here's -3, so we're kind of starting there. If we do the area from -3 until -3, we haven't gone anywhere, so you haven't collected any area, so that would be 0. So -3 is good, want that one. So I guess I can actually get rid of these two, because I know -3 is going to have to be in there. But let's test 0. So if we get area from -3 to 0, that would be this amount right here. And so that's a positive amount of area. That is not 0. So it cannot be 0. And if we go all the way to +3, which would be right here, if we go from -3 to +3, we would get even more area. We're getting further away from 0. So that would not be 0 either. So it's going to have to just be A. All right, this is one of the nastiest problems I have ever seen. That doesn't mean we're gonna, get scared and run away. We're gonna get through it together, all right? It says this is gonna be our substitution, and instead of using U, they used Y, so we gotta get used to that. I guess you could scribble out the Y and put U if you really wanted to, but all these choices have Y in them. I would deal with the boundaries first in this case, because the rest of this is going to be real nasty, and if we at least can narrow it down based on the boundaries, that'll be good. So I'm going to plug in 0 for x. So that square root of 0 would be 0. So I get sine of y equals 0, and that would just be 0. My lower boundary is going to be 0. Let me pull out my unit circle. Got it. Sine of 0 is 0. Sine is the y value of your point. All right, so lower boundary is going to be 0. I actually think they all were, though, so that actually doesn't help us at all yet. All right, plugging in 1/2. Square root of a half would end up being square root of 2 over 2. If you square root a half, square root of 1 would be 1. Square root of 2 is square root of 2. And so that'll be square root of 2 over 2 equals sine of y. So what would that angle have to be? What would y have to be in order for you to get square root of 2 over 2?
Pi over 4.
Yep, perfect. So I need my upper boundary to be pi over 4. So let me see. It cannot be this one, or this one, or this one. So to be perfectly honest with you, if this came up on the AP exam, I would expect you to narrow it down like that and then probably make a guess, okay? Because the rest of this is a lot. Just to bring up before we get there, we're gonna need the derivative of arc sine in here. And I have taught it to you. I told you to make flashcards. It's one of these random things that you have to know, and it's coming up in this problem. So your derivative of arc sine is 1 over square root of 1 minus x squared. So that is going to come up in this problem, so I'm just letting you know ahead of time. All right, so this is the substitution that they gave us. Sine of y equals square root of x. And I'm going to get y by itself. So to cancel out sine, we're going to do arc sine, or sine inverse to both sides. And then we're going to do the derivative. It's like when we do du. Again, it just instead of u, they used y. I guess you can use any letter of the alphabet you want. It's weird that they picked y here. All right, but derivative of arc sine, it's 1 over square root. Now this says 1 minus x squared, but it's 1 minus whatever is there squared. And if I square the square root, they're going to cancel. I'm just going to get x. And then there's a chain rule. So we're going to chain on the derivative of square root, which is 1 over 2 square root of x, and then dx. Okay. Now I'm going to need to multiply this 2 square root of x to the other side, because that's not in the problem. It's not showing up anywhere in here. And then last thing, I can't mix and match the x's and the y's here. But remember, square root of x was equal to sine of y. So I'm going to replace this square root of x with sine of y. Okay, now I'm ready to highlight. In place of this, I'm going to put 2 sine of y dy. So the 2 will go out front, and then I'll have sine of y dy, and we said our boundaries were 0 to pi over 4. And then the last thing that's there that I didn't highlight is this square root of x, and square root of x equals sine of y. So I get another sine of y in here, and so it's going to be squared. So out of these 2 choices, we narrowed it down to it is C. Like I said, that is one of the grossest problems I think I have ever seen. Tons of square roots everywhere. They called it y instead of u. You needed to remember the derivative of arc sine in there. That one was a lot. But again, that doesn't mean it's not like a good problem for us to go over. It's just that one was pretty intense. All right, number 6 was the one that didn't have a correct answer, so skipping that. Number 7, the table above gives values for f and f prime. It is continuous from -4 to -1. What is the value of, and let me just write that a little bit bigger because it's kind of small. So we want to do the integral of f prime. So the antiderivative of f prime would just be f of x, and we want to evaluate it from -4 to -1. So upper boundary minus lower boundary, this is going to be f of -1 minus f of -4. So again, I did the antiderivative, and then we're going to do upper boundary minus lower boundary. So looking at the table here, f of -1 is -1.5. And then f of -4 is 0.75. So subtracting those would be, what is that, -2.25? So B. So what was kind of tricky about that one is they gave you all these f prime numbers that you never even used. We didn't even touch these at all. This was just extra information there to distract you. All right, this is just going to be a basic u substitution. We're going to let u equal x squared. So that derivative would be 2x dx. And I don't have a 2 in the problem, so I'm going to do 1/2 of that. So in place of the x dx, I'm going to put 1/2 du. And what's left that I didn't highlight is e to the u, which is its own antiderivative. And then u was x squared. So that one is A. My problem with these is I'll do the problem correctly and then still pick the wrong answer choice because they all end up looking the same to me. So make sure I pick the correct one. All right, for this one, we're going to let u equal x cubed. And again, if you pick the wrong thing for u, it's not going to work out, and then you'll catch it and be like, oh, I guess I better pick something else, because everything has to match perfectly in the problem. So this derivative will be 3x squared. I don't have a 3 in the problem, so I'm going to do 1/3. And so in place of x squared dx, I'm going to put 1/3 du. And so what's left that I didn't highlight is cosine of u. So I need an antiderivative for cosine. I need a function that if I did the derivative, I would get cosine, and that is going to be sine. And then u was x to the 3rd. So that one is B. And then last one, we're going to let u equal 3x, the inside part. That derivative is just 3 dx. I don't have a 3 out here in the problem, so we're going to do 1/3. So the only thing I get to highlight in this one is dx. That's okay. In its place, I'm going to put 1/3 du. And what's still there is sine of u. And then I need to adjust the boundaries. So if I plug in 0 for x, 0 times 3 is going to be 3. Or 0, sorry, I can't talk. 0 times 3 is 0. And if I plug in pi over 3 times 3, that's going to be pi. The 3's will just cancel. So I need an antiderivative for sine. I need a function that if I did the derivative, I would get sine. And that is going to be negative cosine. So I get negative 1/3 cosine of u from 0 to pi. So plugging in pi, pull out my unit circle again. Here's pi. Cosine is the x value, so that's going to be negative 1. Times negative 1/3 would just be 1/3. Minus, and now I'm going to do cosine of 0. So here's 0 pi. Cosine, again, the x value is 1 times negative 1/3 is negative 1/3. So the negatives are going to cancel. 1/3 plus 1/3 will be 2/3. So D.